Hello students, welcome to the new video. Today we are going to discuss about circles. Circle can be described as, let me draw first. This is a circle. Suppose this is the center of the circle and it is a radius, suppose r of 5 centimeters. So what we can say about circle? Circle is nothing but a collection of points from a center in a plane which are at an equal distance. As we can see here, it is equally at all the distance, at all the point from the center on this are at the same distance. So this is r equal to 5. So this is circle. There are some properties and some theorems based on circle which are useful for your examination as well as your future purpose. So what are those? Suppose, let me draw a circle first. This is a circle. This is the radius. Let me use another pen. Of suppose r is equal to 5 centimeters, and this is the diameter. Complete is the diameter. Diameter is equal to 10 centimeter. As you all know, diameter is twice of radius. Diameter equal to double of radius. So now if I draw a line segment here outside the circle, suppose this is A, B. So this is one possibility, but it is not touching the circle. Another possibility of it can be, suppose this is the circle of radius, again we are taking as 5. Now if I am drawing a line segment cutting the circle like this, intersecting circle at point A and point B, so now this line segment will be called as secant of the circle. As it, for secant of a circle, the line segment should touch 2 points of the circle and intersecting the circle. This is the basic requirement for the secant of the circle. Now if we draw another circle, suppose this is circle, this is the center of the circle, and if I draw a line segment touching only, this went wrong, only 1 point. Suppose this is MN and touching at O. So this is known as tangent to the circle. Right? This is known as tangent to the circle. Now what is the difference between a secant and a tangent? A secant is a line segment which touches the 2 points. Here it is touching 2 points of the circle, whereas a tangent is a line segment which touches only a single point on a circle. Right? Now if we draw a circle, suppose this is a circle, this is the radius, and this is a point at the circle, on the circle. So at this point, suppose this is a one line segment, but this will not be treated as tangent because it is intersecting at 2 points, this point and this point. So this is a secant. But if I draw another line, it is touching only this point. This is a tangent to this circle. So this is the major difference between a tangent and a secant of a circle. Now there are some theorems related to tangents. What are those? This theorem number 1 states the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now what does that mean? Suppose this is a circle and this is the radius, right? And there is a tangent passing through this circle as AB. This is tangent to this circle. So suppose this is O. So what this theorem states that the intersection of this radius and the tangent at the point of contact will be perpendicular. That means this angle will be 90 degree always. Right? So this thing you have to remember, that this angle, suppose this is M. So angle OAM is equal to 90 degree. Is also angle OM is equal to 90 degree. Right? Also remember, footnote, the tangent to a circle cannot lie within the circle. That means, what is this? Suppose this is a circle. So if it touches this point and if it goes like this, then this cannot be treated as a tangent. Right? Remember this. This is a very important point. Don't get confused. If the tangent will always, it will always and always pass through only one point. And students, for convenience, you can watch this video at 1.5x. If you are thinking that it's going a little bit slow, then you can go through at higher speed for a better experience. Now comes the second theorem. This is one of the most important theorems of the circle and for the tangent. So the lengths of tangent drawn from an external point to a circle are equal. Now what does this state? Suppose this is a circle, this is the radius, and this is center O, and there is some point M outside the circle. If I draw one tangent like this and one tangent like this. Suppose this is A, this is B, and point of intersection is N and K. Right? And let me join this as well with the center. This will be 90 degree. This will be also 90 degree. Right? So what we can, how we can say that the length of the tangent will be equal? That means this theorem states that Mn will be equal to Mk as per this theorem. Right? Now, if you have learned about triangles, as we know, these two are the right angle triangles. This triangle M and O and triangle MOK are right triangles, right angle triangles. So if they are right angle triangles, then in this circle, this ON and OK, ON will be equal to OK because radius, this OM will be equal to OM. That means because there is a common line. So, and there is one right angle triangle, right angle. So by RHS congruency, we can say that triangle MNO is congruent to triangle MOK. Right? If this is true, then by CPCT, that is corresponding parts of congruent triangle, we can say that this Mn is equal to Mk, hence proved. So you need to remember how to prove, you need to understand how we prove the theorems. This will help you to understand this theorem as well as the concept which is there, that how this Mn and Mk are equal, right? Also, in this there is one more way that can be used by Pythagoras theorem. Pythagoras theorem can be also applied to prove this, right? So how can we can prove this through Pythagoras theorem? Now, if we go back to this figure, what we can see here, this M and O is a right angle triangle. This MOK is a right angle triangle. So if any of this triangle, if I apply Pythagoras theorem in M and O, let me take this figure here as well for the convenience. In triangle M and O, if I apply by Pythagoras theorem, this is 90 degree, so this is gonna be hypotenuse. So OM square is equal to, hypotenuse square is equal to base square plus perpendicular square, right? So this gives Mn square is equal to OM square minus ON square. Now, because of this circle, this ON and OK are equal because they are radius, right? This ON and OK are radius. So what we can write here is Mn square is equal to OM square minus OK square, and this gives what? Mn square is equal to this, we will get, if we will apply Pythagoras theorem in triangle MOK, then it will give you Mk square. So if you take square root on both sides, square root in both sides, we get Mn is equal to Mk, what we need to prove. So this is the way we can prove. There's another way to prove this theorem, whichever you like. So this is for the this video. Hope you like this. If you like, share it to your friends and stay tuned for more such videos. Thank you.